Okay, so yesterday we did this height versus wingspan lab. The point was to collect data. Our success criteria is actually that we can create graphs that properly represent data, which we're going to work on today. So, got to know a little something about graphing, what's expected, how to do it. And if you weren't here yesterday, I will get you a handout. And I did put all of the data on Google Classroom. Hopefully you've all joined Google Classroom. If you haven't joined it yet, you should. And I'll put that up with the code in a little bit. So what we've kind of been going over is Pod C, and a lot of times what this could be used for is really just getting us to the hypothesis phase. Which, remember, the hypothesis is a suggested answer we want to use complete sentences on that. And we want it to be testable. Something we can test to see if it's right or wrong. All right? So Pod C could take us through the whole process of an experiment, but a lot of times it leads us to the hypothesis phase. And what comes after hypothesis, we get to the experiment phase. And the reason why I'm going to focus on this is because what happens during the experiment phase is we collect data. And that's what we did yesterday. Okay. We would also have detailed procedures that we would write out, a plan for what we're going to do, follow those procedures each time we do the experiment so that nothing changes. Because we want to be careful of our conditions, careful of our settings. So these things that we're thinking about is each time we do an experiment, we're trying to test for something, okay? And we don't want to change more than one thing during an experiment, because then if anything changes, anything is different, we won't know what caused the change. So we have these things called constants. So these are things we always keep the same with each trial, so that everything is exactly the same except for the one thing we're testing. All right? So if we have something that changes, the thing we're going to test, we call that the manipulated variable. So this is the thing we're testing. So we make this change on purpose. So to kind of clarify it, an example I give each year would be, and I tell you that we apply science all the time, just anytime we do problem solving. So let's say that I am leaving school and I'm driving home. I told you guys I live kind of far away out in Royal Oak. And I'm driving up 275 and I take it all the way up to 696 and then over east to Royal Oak. And I'm driving along, I'm like, man, this takes a long time. I wonder if there's a faster way to take. And then I also know that I could just take 275 to 96 to Southfield up to Royal Oak. I could also do that. So I've got a couple different routes that I can take. There's a couple different routes I could take. So maybe I decide, hey, I'm going to do a test. I want to see which way is faster. Okay? So the thing I might change in this test to see which way is faster, if that's my problem, I'm going to change the route. So in that scenario, my route home that I take would be the manipulated variable. That's the thing that I'm changing on purpose. Okay? Now, what are the chances that each way I take is going to be exactly the same amount of time? Probably not that good. So something else that might change as a result is called the dependent variable. So this changes because of the manipulated variable. So if I change my route and I find that the different route takes longer or it's shorter or whatever it is, it's still something that's different now. But going back to those constants, I want to keep everything else the same. The one thing I'm going to change, the only thing that's going to change is the manipulated variable, the route. I don't want to drive one way and I'm speeding and then drive the other way and I follow the speed limit. I don't want to drive at different times of day. Drive one time early in the morning and then another time I drive home, drive the route in rush hour. That wouldn't be a good way to do things because then I don't truly know what factors are affecting how long it takes me to get home. Is it the route or is the fact that there's more traffic? I don't want to use a different car. I don't want to do it, drive home one time in the fall and compare that time to driving home in the winter. That makes sense? So I have to talk about these variables for experiments. We got to know what they are in order to properly graph data. Okay, so this is how we're going to apply it to graphing. So there are different types of graphs I can make. I could make a bar graph. I could make a line graph. I could make a pie graph. You've probably heard of all these, right? If I'm doing the two routes and I wanted to graph that, I would probably use a bar graph actually because bar graphs are good when you're doing comparisons. What we're going to be dealing with more though are going to be line graphs. So let's say, talk about our lab, height versus wingspan. Okay, so the first thing we got to make sure we do is title the graph. And if you've ever got a data set given to you and you're not sure how to title the graph, just title it the same name as the data set. In this lab, the whole point is to measure height versus wingspan. Okay, so I'm going to make sure I have a title. So that's the first thing I'm going to make sure I do. The second thing I need to do is identify, this looks like axes, but it's plural form of axes. So we have two axes, one that goes up and down like this. If you're in math, you might see this as a big like plus sign almost, because it involves negative numbers too in math. But in science, a lot of times we just deal with the positive. So we make a graph like that. So we've got one graph that goes, or one axis that goes up and down, and that is called the y-axis. Okay? The y-axis goes up and down like a yo-yo. Yo-yo goes up and down, right? Yo-yo, y. And then you have the one that goes sideways horizontally, and that's the x-axis, like a xylophone goes sideways when you play a xylophone. Okay, so those are the two axes. Now, the reason why it was important to understand the variables is because that will tell us which variable we should put on which axis. So the way to remember it is actually called dry mix. Yep, you guys have heard of this before? Okay. And what this means is the dependent variable, which is also sometimes called the responding variable, goes on the y-axis. And the m is the manipulated variable. All right. It's sometimes called the independent variable, the I, and that goes on the x-axis. So dry mix. Dependent goes on the y, and the manipulated goes on the x. The reason I like to use dependent and manipulated specifically is because I think it's a lot easier to understand. Manipulated, it makes sense. If you manipulate something, you're trying to change some kind of outcome for some reason, right? If you manipulate somebody, you're trying to do something. If you manipulate something with your hands, you're trying to do something with that. So manipulate is something that you do on purpose. If I did a magic trick and I changed something on purpose, that's something I manipulated. Yep, absolutely. Yep. So the other thing that's good about it is the dependent variable. So if I know my two variables, I know the two things that are changing. And these are going to be the two things that I see in data tables when I'm doing graphing. In this case, it's height and wingspan. All right. I can just ask myself, does a person's height depend on their wingspan? Or does their wingspan depend on their height? Which one sounds better to you? Now, this one I'll tell you, if right away you're going, wait a minute, they both sound right. Usually, it's a little clearer than that. In this case, it's a little more difficult. Is how wide the person's reach is, does that depend on how tall they are? Or how tall they are is because of how wide their arms are? So the wingspan depends on a person's height. Let's see. Show of hands, everybody please participate. So that means if you don't raise your hand, that means you disagree. So I'm going to say, raise your hand if you agree that the wingspan depends on their height. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Avion, did you have yours? 21. All right. I tend to agree. I think that sounds a little better. All right. So that means that if we say the wingspan depends on the height, then that means that we are going to put the wingspan on this axis. Okay? Which then means that the height must go on this one. Okay? When you're labeling the axes, not only is it important to put the right variable in the right place, it's very, very important to put the units down. All right? What were the units for these? What was it? Was it millimeters that we measured in? Centimeters, okay? So I'm going to put little parentheses here, cm. And I'm going to do that on both of them. So that means that any numbers I put along that axis are automatically going to be centimeters. Okay? All right, so far so good. All right, the next thing we have to do is we have to determine the scale for the axes. Probably should have gotten like a picture of a graphs on here so I could just do it on here, but so the scale, we got to consider two things, range and marks. Let's say I'm making my graph. Don't write this down. Don't do this. Say I've got 4 marks like that. Okay, so I've got my 4 marks. Don't do this. And I go 5, 10, 15, 20. I'll go by 5s because I like going by 5s. Is that a good idea? Why not? Data probably won't fit on this. Did we have anybody in here that was 5 centimeters tall? Be kind of hard to see them. I think our data was probably going to be, if I were to put it up here, would probably end up being somewhere over by the door, right? So we want to make sure our range covers the data that I need to graph. So that's step 1. Identify the range. And the range is going to be, what's your lowest number to consider? What's your highest number to consider? So you guys are going to have to look at all your data. You have that class data. Again, I did put all the class data on yesterday's Google Classroom if you need to check that. Or when you're working with somebody today, you can just get it from them. But lowest, whenever possible, I like to start at 0. Just put 0 here at the origin. Seems to work well whenever possible. Any idea what our tallest height was? Let's say it's 200, okay? Say it's 190, okay? When we're doing our range, let's go a little past our highest mark, all right? So I'm going to make this 200 at the top. I got to go all the way to 200. Now, I got to make sure that each of those marks, since they're evenly spaced, I got to make sure that they're all worth the same amount, which means I have 1, 2, 3, 4 marks. I got to cover 200 units, in this case 200 centimeters, with 4 marks. So any idea how much I should make each mark worth? You say 50? 50 should do it. I think you're right. I could take that range, that difference, 0 to 200, which that difference is 200, and I can divide by the number of marks. As Jaden just said, it looks like 50 should work, okay? And if I plot those up here, 50, 100, 150, 200, seems to work out pretty well, okay? I'm going to do the same thing for the wingspan side. Maybe not necessarily the same scale, but I can say from doing this lab before and observing you guys yesterday that probably the same range on the wingspan, right? It's about the same, was it? Wasn't it? About the same. Now, here's another thing I want to point out. If you're ever in a situation where you're writing larger numbers like that and there's not much room to write, you don't necessarily have to label each mark. I could just say, okay, each one's worth 50, which also means every 2 is worth 100. You could also do that just to show you, okay? If you figure out how much each mark is worth, you don't necessarily have to do every one. Maybe your range is 100 and you have a ton of marks so that each mark would be worth 2. Well, that's going to be a pain in the butt and crowded to go 2, 4, 6, 8, 10, all the way up to 100. So instead, what I would do is just go every 5 marks, I would mark 10, 20, 30, okay? Now at this point, we're just going to look at our data and plot our data. So that would be the 4th step. Okay, now this depends on what kind of graph we're doing. Like I said, we're doing line graphs. We also need to put I'll put this as 4B. We also need to consider if we need a key or not. And I believe in this lab, they're saying that you should make 2 line graphs, really. One comparing the guy's wingspan and height, and then the other one is for the girl's wingspan and height. Okay, so if that's the case, I got to be able to make 2 graphs that are different. So, I mean, I can do it pretty easy because I've got different colored markers up here. I do have colored pencils and things if you need them. If you don't have different colored things, you can always make a different pattern to the line that you make. But so I'm just going to plot the points. So maybe somebody had their height was 150 and their wingspan was about 150, somewhere around there. So I would just go height, mark my way over here to 150. It's right there. And then if these are the same, I would go up to 150. Boom, make a point. And I keep doing that for all of the data I have. So that's going to take a while because we got a lot of data in here. Might have some outliers somewhere. What is that? Okay. If we want to do a line graph through this, we're going to try to start right here at the origin, and we're going to try to just draw a straight line right through the middle of it. Okay. So let's say this is the guy's data. Actually, I could do a straight line. This works well on here. So guy's data, I can draw this out here. Something that goes through the middle of the data. Does that look pretty good? Boom. And that's the guy's data. Then what I'm going to do is I'm going to plot the girls. And let's say I don't have different markers. I plot the girls and, whoa, oops, I forgot I was making lines. My bad. All right. Maybe when I'm plotting the girls' data, maybe instead of dots, maybe I want to do little X's just so I can remember, okay, this is the girls' data, so I don't mix it up with the guys. Something like this. All right. But then same thing. I'm going to draw a line through it. Now, but this line, I might like to make different. So maybe for this line, maybe I'm going to make a dotted line. All right. And again, I'm going to start at 0, and I'm going to try to go through the middle of the X's. And really, it's going to be about the same, I think. There's a few more down below. That might pull it down here a little bit. You kind of eyeball it. All right. A lot of times when we do these lines, they're called best fit lines. We try to make the same number of marks on each side and just try to go through. This dot up here, by the way, you'll notice I kind of ignored this one because it's just all by itself out there, which means it's an outlier. There might have been a mistake. There might have been an error on that. Okay, we can ignore that. We don't have to necessarily consider it part of our data. So do you guys have any questions? Oops, I didn't make my key. So off to the side, I would have a key, and it would say something like boys, straight line, girls, dotted line. All right, so that somebody reading in the graph can tell what it is. So you guys have any questions about graphing at all? Good. All right.